Hi, my name is Mark, and today I'm going to show you how to make your C and C++ builds faster with ccache. We're going to start with a fresh Docker image, fresh Ubuntu container, so you can try and follow this at home. We're going to run apt update to update the software packages, and we're going to install some software required for this tip today. So I'm going to install wget for downloading something of the internet. Going to download the editor Vim. I'm going to download ccache, so this comes basically available at all the Linux distros, and I think it's also available for Homebrew for your Mac if you're into that. And we're going to install the GCC and G++ compiler tools, which is called Build Essential, which is going to have a lot of libs essential to build stuff with C and C++. Okay. Today we're going to use a library from Google, which is called libwebp. WebP is an image format for the web, which is much smaller than PNGs and JPEGs and has lots of nice feature. And we're going to use that because you can only see the effects of ccache if you have a little bit larger and more complex C and C++ project. So now that the stuff we went to install is installed, we can download the WebP source code. So I'm going to copy the link address of the web page, and I'm going to download that. So, and let's unzip this xzf libwebp. Okay. So, we're going to start with a simple example first. We're going to start at the very beginning that every developer does it at the first time, which is a hello world program. So I'm going to create a hello world.c file. Okay. I prepared the hello world source code here. Nothing interesting so far. Okay. And the file is written, so if I see this here, you can now see the file hello world.c here. And let's try and compile this. So we're using the GCC compiler. We're going to compile the hello world source file, and we're going to basically create a program named hello. And as you can see, this was really fast, so don't really know if you see, but we have now created the program hello, and we can run this with /hello. Nothing interesting so far. So I can't really show how ccache works at this scale because this file is just too small to make any effect, and it actually isn't really cached by ccache. But as you saw, like in the command, we use GCC directly to compile the hello world program into a hello program. And the way ccache works is that you just tell it to run ccache, and ccache in turn will run the GCC compiler. So you just just add ccache in front of GCC. And now ccache did its magic, but nothing happened so far. So I can remove the program again, I can run this again. And the way this works is that ccache creates a hidden directory in your home directory that contains the output of these programs. So the basic principle is if you run a compiler with the same flags and the same source file, then it will always generate the same output. And ccache uses this. So we can use the ccache, we can just call the ccache binary directly, so we get some nice help. For example, we can show the stats for the current ccache. So I'm gonna type that. Okay. And as you can see, it shows where our cache directory is. So there it has the cache. It tells us how high the cache hit rate is. It tells us the cache size, which is 5 GB by default, as it seems. But it didn't work for the Hello World program. So Now let's go into a bigger program. So as you saw, we downloaded the libwebp library, so we're gonna enter that directory. And this is a really complex project, so the way this works is usually we just type configure to make the program, so you can read this all on the libwebp source page, so it's all in the README usually, and now it's configured, and we can now try to compile this. But let's stop a little bit. How would the compiler chain and how would the makefile know that ccache is available? Actually, right now it's just installed, but usually if you restart your computer, then ccache already configured your path, so we didn't have this here. So we have to basically tell the compiler chain that to use ccache all the time. So if I type which GCC, we can see that it's using the GCC program directly. So if I now copy this over, and if I see, it's just the regular GCC compiler, the GCC. Yeah, and now we can't really tell it, to use ccache all the time, so we would have to mess with the program. But ccache has a really nice thing, which is if you it can be configured as a symbolic link for all these compilers. And the way this works is usually that you configure the path and tell it to use the ccache directory as the first directory in your path. So I'm gonna copy that over here. And now if I'm telling it which GCC to use, then this user bin GCC thing, let's see, no, usually it should have worked like at this point in time. Let's see if I have this done correctly here. So let's look into this directory. Oh, it's not there. Oh, did I install it? Let's check. It's already installed. So, yeah. Oh, it's a different directory, I guess. Ccache Ubuntu. Okay, seems I tried this the first time. Oh, it's in a different library. It's in user lib ccache. So we're gonna copy that one over here. Sorry for the little hiccup. Okay, and now if we call which GCC, it will tell us that it's using the GCC symbolic link in this directory. So we're gonna have a little look how this looks. Okay, now this GCC is just a symbolic link on ccache. So now every time we call GCC, it's actually calling ccache, which in turn calls GCC. Okay, and now let's use it. So we're going to compile the libwebp library for the first time, and of course the first time ccache won't know anything about it. So I'm going to type time, so we know how long this build will take. We're going to type make to make this project, and I'm going to type J4 to use 4 threads for compilation. So basically compiling 4 files at the same time. Okay, let's run it. So this should take 30 seconds or so. As you see, the libwebp is quite complicated, so there are quite some files with this, and it's going to generate the libwebp library, and it's going to create the cwebp program, and it's done. And basically it took like 43 seconds, I guess. Yes, 43 seconds. Okay, and now if we look at the stats of ccache, so I'm gonna type ccache again. Let's see the stats for ccache. Okay, and as you can see, now we have 17 megabytes of content, and we have a 0% hit rate because, of course, the first time ccache didn't know anything about the library, about the compilation, and so it really couldn't reuse the stuff before. So now I'm gonna clean the whole project, so it needs to recompile all these files. And now, regularly, if I wouldn't have ccache activated, then this would take the exact same time or around the same time as the first compilation. But now, because we have ccache activated, we can run the same command again, and ccache will automatically reuse the compilation from before. And this is gonna be much faster. So it took like 7 seconds user time or 8 seconds in real time. So it's yeah, it went quite well. And now let's see the ccache stats again, because those are getting a little bit more interesting. Now we have a cache hit rate of 50% because, of course, the first time around it was 0%, and now we had it the second time. So if I'm gonna make clean and erase all the files again and run it in another time, then it's gonna take around the same time as the last one with ccache. But now the stats are gonna be different. Okay, now we have a little bit higher cache hit rate. And I think this tip is really, really helpful for your C and C++ compilation projects because it makes things so much faster. And what's really nice about this is that you can also use it with your ObjectiveC builds. So it also works with ObjectiveC and ObjectiveC++. Yeah, I really hope that you can make your builds faster, because faster development time is just better and makes developers happier. Thanks for watching.